In this case, if you want to make any entities with the help of the curve, you can do that thing by using the one tools that is called equation driven curve. You can get from this drop down menu equation driven curve. If you can use this tool in the 2D environment or in the 3D environment. Suppose I go inside the 2D sketch in the front plane, and when I activate this tool, at the time you can see I have two options, explicit, parametric. I will work with the explicit first. I have to put the equation first and the parameter. For the equation, I will put very simple equation here, and for the parameter I will put 0 to 10. After putting this information, you can get this result. This is, if you know this equation, this is a straight line equation. That's why I got this straight line equation. When I press OK, say this is a straight line equation. In the front plane, this is totally straight line. And if I want to change not 0 to 10, 0 to pi, I can use the pi, and this is that pi. Or if I want, I can change the equation from this to cos x. So I can get different result based on my equation. If I put 0 to 10, I will get this curve. So in the explicit type, I can put only one equation. In the parametric type, I can put two equations with the two equation for the x, y, and the parameter will be the t. Here first I will put two equation. I will copy the equation because it's very large. It will take time to write. You can just follow with me. This is that equation, and for the equation t value is 1 and this will be the 5. Let's see what happened here. This is the equation I got. Suppose I make few more geometry here. Now if I revolve surface, I can get this result by using that equation, and it's very accurate. You cannot get this very accurate result from the manually drawing. Now if I change this revolve from that line to this line, for the same equation I also can get this result, and this is very accurate. So by using this equation, you can get the most accurate result. So far you have seen the two different type of equation driven curve in the 2D environment. Now I will show you in the 3D environment. In the 3D environment, when I activate this tool, you can see there are three equations here and two parameter x, y, z. For the x, I will put 5t. For the y, 1.25 cos 5t now, 5 into t. And for z equation, 5 into cos t. And for the parameter, for the t1 0, for t2 2 into pi. After putting this information, I can get this result. So this is that curve. If you want to make this curve manually, if you want this shape manually, it's very challenging. By using this equation driven curve, you can make this very easily. I will show you another type, not another type, I will show you another curve in the 3D environment. I will activate equation driven curve, then I will copy and paste the equation because it's very long equation. There are lots of different type of equation you can create. If you understand the equation, you can create lots of different type of equation. This is my equation. When I click on this graphic window, you can get this is very nice curve here. You can modify this curve from here. If you change this to 20 and this is to 20, you can get this different result. When I press OK, this is my equation driven curve and it's very accurate. You can get lots of different type of equation by using this equation driven curve.